Here's a question. How do you steer something moving at more than 99.99% the speed of light so it can move in a giant circle 11,000 times per second? Because that's what happens to particles inside the Large Hadron Collider at CERN in Switzerland. Here's how they do it. Here's the problem. The particle beam wants to travel in a straight line. That's Newton's first law of motion. So to coax the beam into a curve, certain scientists use magnets. And these aren't just any magnets. The LHC uses more than 1,000 giant superconducting electromagnets to steer the beam. Each one weighs 35 tons. That's like 7 elephants. And they're all kept colder than outer space using liquid helium. The dipole magnets that steer the beam rely on something called the Lorentz force. By creating a magnetic field in this direction, a particle moving this way experiences a force toward the center, causing its path to turn. Why do the electromagnets have to be kept so cold? Because they carry 11,000 amps. That's almost as much as a lightning bolt. And because they're made of superconducting materials, those magnets don't lose any energy due to resistance. But there's one more problem. The particles in the beam want to repel each other. So if they were left alone, the beam would just scatter off the walls. To keep the beam focused, 400 quadrupole magnets work like contact lenses to focus the beam tight. That way, when the LHC's two opposing beams are aimed at each other, particles collide head on and boom. We can recreate the most extreme conditions in the history of our universe. So we can keep figuring out what all of this is made of. If that's not awesome, I don't know what is. Follow me for more cool science stories.